So let's do an example problem. Let's say that we have a wire that has a mass of 13 grams. It's suspended, free to move, like that. Let's say the wire is 62 centimeters long. And it's in a magnetic field, and the magnetic field is into the screen. And let's say the magnetic field here has a strength of 0.440 Tesla. So the question is, what direction and magnitude does the current have to be in order to levitate that wire? So it's free to move, and I want it to be hanging there, levitated, suspended in space. So it's not falling, so it's on springs here, and there's no tension in the springs. It's levitating. So what do? Well, we need to have, obviously, we need an upward force on it. So to get an upward force, we got to have current in a magnetic field. So if the magnetic field is into the board, okay, then we have two options for current. We have one option is the current goes to the right. The other option is the current goes to the left. Okay, so here's the magnetic field. Now, the question is, which one gives us what we want? Remember the right-hand rule. So you do the right-hand rule. The way I do the right-hand rule is I put my hand in the direction of the current. Okay, I curl my fingers in the direction that the field goes. So if I do that for this, that's a force that's up. If I do it for this, that's going to be a force that is down. Okay, so that one is not the one we want. So this is the one that we want. So that means I asked for the magnitude and direction of the current. So the current is obviously going to the right. Okay, now back over here. So we got our wire here. It's suspended. Free body diagram on the wire. We've got mg pulling down, and we've got the magnetic force going upwards. Now, how big is the magnetic force? The magnetic force on a wire is ILB if the wire and the magnetic field are perpendicular to each other. If they're not perpendicular to each other, then we've got sine theta in there. Well, in this case, theta is 90 degrees, so that's just going to be equal to 1. So it's I times L times B. So that means the force up has to equal the force down. So ILB equals mg. So that means I equals mg over LB. So the current is going to be 13 grams, 0.013 kilograms, times G, 9.81 meter per second squared, divided by L, and the length was 62 centimeters, so that's 0.62 meters, and then we have 0.447 as, 4.440 Tesla as the magnetic field. Plug all that in, and what you come up with is 0.47 amps. Okay, so there is the magnitude, and the direction is to the right. Okay, so that's how you do that problem.